5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
This is About Space, America's return to space, with news and information on our U.S. space program. Is your host of About Space, David Denault.
Welcome and thanks for joining me today. If you have been following our investigation into time travel, we've learned about the life and achievements of Albert Einstein. And we learned how the Alcubierre drive functions and the thoughts of Derek Demeter, astronomer and director of the Emil Buehler Planetarium in Sanford, Florida. In About Space today's investigation, I'll share what NASA has concluded after its research. The NASA Report, next on About Space Today. About Space invites you to be our guest for the next SpaceX Crew 3 launch on Saturday, October the 23rd. Be our guest with overnight lodging at the Best Western on Cocoa Beach with a full breakfast and all the amenities at the Oceanfront Hotel, plus 2 tickets to see the Kennedy Space Center. So come, be our guest. Just go to our special website, aboutspacetoday.godaddysites.com. That's aboutspacetoday.godaddysites.com, and enter today and be our guest for the SpaceX launch. Welcome back. He serves as the Advanced Propulsion Theme Lead for NASA in Houston, Dr. Harold Sonny White.
So you could ask the question, what if you wanted to get somewhere very quickly? What if you wanted to try and cover that distance from Alpha Centauri in some time period that's not measured in decades, centuries, or millennia? What if you wanted to make it in less than 4 years? It turns out that the same framework that establishes the speed limit, the cosmic speed limit, you cannot exceed the speed of light. There are 2 loopholes within the mathematics of general relativity that potentially allow you to go somewhere very quickly without locally leaving your local light cone. One is the idea of a wormhole, the other is the idea of a space warp. And I'll talk a little bit about that. So the idea of a space warp works on the principle that you can expand and contract space at any speed. It's not restricted to c. We know that inflation occurs in nature when we look at light that comes to us from stars that are in galaxies very far away from us. That light has been redshifted since the Big Bang 13.7 billion years ago. So we know that inflation is a real phenomena, and it's part of general relativity. And so nature can do it. Can we do it in some purposeful way? And so it was this idea that motivated Miguel Alcubierre to publish a paper in the 90s that kind of captured this idea in mathematics. And so when you look at the math and you try and envision what it might require, donut type of apparatus that surrounds this little football shape spacecraft. And so the football shape might be where you'd have your sensitive instrumentation or any payload that you're very worried about. Or if you wanted to be bold, maybe some type of a human crew. Now the metric had a lot of good appealing characteristics when you think about the idea. It has a couple of good characteristics for the concept of a mission like this. It has the divergence of phi is 0, so it has flat space-time inside of the bubble. The coordinate time is equal to proper time inside of that flat region. So the mission control clocks would be synchronized with the clocks on board of the spacecraft. Then the proper acceleration alpha in the bubble is formally 0. So when you turned on the space warp system, the whole crew would not feel an infinite acceleration and go smacking against the bulkhead and killing everybody on board, and making for a very sad episode of Star Trek. Now, it does have one unappealing characteristic. After Miguel published his paper and people went to go try and figure out how much stuff would it take to make this concept work, because it requires exotic matter or negative vacuum energy. And so they did some calculations to figure out what would you need to make some type of a system that we would think about actually work. And so the best estimates that were done prior to 2011 were done by some colleagues of mine, Dr. Richard Abusi, Dr. Jerry Cleaver. They reduced the amount of stuff that's required to something that's about the size of Jupiter. And so that's just quite impractical. And so the concept was really considered maybe nature can do it on a grand scale, but it's unlikely that we could ever do something like this in a purposeful sense.
NASA says it's unlikely that they could ever achieve anything like time travel in a purposeful sense. What do you think? The U.S. government report on unidentified aerial phenomena, or UFOs, said they do not have any idea where they come from, or they're able to explain the incredible speeds and maneuvers to stop on a dime and then launch for thousands of miles an hour. Time travel? Look how long it took to prove Einstein's theory of relativity. But it was done. And let's not forget the man who started the idea of time travel, and the story that launched H.G. Wells' successful career in 1895 and earned him the reputation as the father of science fiction, with a speculative leap that still fires our imagination today. And be sure to have your family and friends listen each Tuesday with me on About Space Today, and on Fridays with America in Space with Don Meyer from Florida's Space Coast. And follow us on Facebook for space news and updates at aboutspace.today. And our Tuesday shout-out goes to our neighbors to the south in Chile, with its many listeners who enjoy our weekly programs, and to all our friends and listeners around the globe and here in the U.S., thank you for listening. I'm David Denault, and this has been About Space Today.